Once the labels have been created, the changes can be checked against any hard copy documents or any tables that you might have. So a listing of the alignment may be useful to help you find any errors. To create a listing or a report, we go into Reports, Strings, Superalignment. We're going to create a report for all the alignments on view number 1. We're just going to leave our report type as simple text and give it a report file, which we will call Roads Table. And click on Report. The file will then be opened up in your text editor, and you can go through and check it against any other paper documents you may have. And it starts out for GCO1, which is road number 1, the horizontal geometry, followed by the vertical geometry. Once again for GCO1, which is road number 2, horizontal and vertical, and finally GCO3, horizontal and vertical. You can then finish on this. We can also check our alignment strings by profiling them in a section view. Before we do this, we're just going to read in the existing surface. So we can go to File IO, pick on the data import from the 12D ASCII, click on the folder icon, go up one level, and we should have a file here called Genio Road Existing Tin, and we can just click on Read and Finish. This will then be turned on in our data input view. We can see that it's a tin, and we can just close that file, that view down. Before we profile our string, we need to create a section view. So click on the Create New Section view and give it the name Long for Long Section, and click on Create. You can then highlight Plan View number 1 and go to Windows, Tile Vertical. By highlighting Plan View number 1, it'll keep it on the left hand side. We can then profile road number 1 and turn on the tin ground. And we can check using our data at the top here for our curve lengths and our grades against any plan plots or long section plots that we may have. We can do the same for road number 2, and similarly the same for road number 3. It's also a good idea to check your cross sections. At the moment we don't have any cross sections because they're typically not included in a Genio file. So we're going to create cross sections from cuts through strings of our models and compare them to any typical sections we may have. So I'll just expand out view number 1 and turn on the models road 1 design. At the same time, we can turn off our models road 2 alignment and road 3. And to create the cross sections, we just zoom in. To create the cross sections, we can use the option inside our setout panel called Cuts Through Strings. The data that we're going to cut through, we can either middle mouse button and click on one of our strings, or we could have selected it from the list. Our sections we want every 10 meters. We want to go out 50 meters on the left and right hand side, so that's okay. Click on the clean models beforehand, even though they don't yet exist. It's a good idea to tick this on in case they do. We're going to call this, I like to select the same name and then add the word sections to the end, and the color will make them magenta. We click on our road centerline. Make sure you keep clicking until you actually get the super alignment string. There it is. We can leave the start and end chainages and then click on Cut and turn that model on. To view the cross sections we created, we're going to create another section view, and this time we'll call it Cross and click on Create. We can then minimize our long section, click back on plan view number 1 and go to Windows, Tile Vertical. We can finish on this panel, but before we finish on it, in case we need to rerun these sections again at a later date, it's sometimes a good idea to save it as an SLX file. So we click on the little icon up the top here, we go to dump, and we're going to save it as an XML screen layout file, and we can click on dump and finish. So now if we were to recall that panel, you can see it comes in, it's not filled out. However, if we went to File IO, Layouts, Layout Input, we could call up Cuts from Centerline and the panel would be filled out for us. So for example, if we only wanted to create the sections as far as our tin covered, which was down to here, Chainage 138660, we could then hit cut again, and you can see that because we've got clean cuts models beforehand turned on, all these other sections will then be deleted. If I turn off our tin, you can see it finishes at this section here, and finish. We can now profile any one of our sections, accept it, and turn on the model tin ground. Because we're looking at sections, we don't need an exaggeration of 10 times, so we'll change that down to 2 times and toggle on our grades. We also want to turn on a grid on our view, so we use the option down here, Grid on View, and we click on the Draw Grid, and we'll change our X grid to 5 and our Y grid to 2, and click on Set. This just helps us to be able to visualize a little bit easier the offsets and also the heights. Click on Finish. It's also handy to be able to visualize things to extend your natural surface tin out a little bit further. So we go into the Settings button here and click on Extend, and extend it out to the left and right by 5 meters, and click Set and Finish. If we had one particular string that we wanted to highlight, we could right click on the profile button and select Model Strings. We can then be asked which chainage you would like to have a look at. So you can just type it in. So we'll try 137840 and hit Enter. You'll notice that in the section view, the section highlights, and it also highlights inside our plan view. While this may be a good thing to be able to see where you are, it's easier to see where you are by moving your cursor back and forth. And what this effectively does is it locks this view if you do a recalculation of this design. So we turn off highlight.